If you are visiting our channel for the first time, please subscribe first to get the latest updates. In today's lecture, we are going to learn how you can find the derivative of the exponential functions or the function involving the exponent or the exponent form by using the product rule. If you came across the two functions that are in multiplication with each other, and there is a function that is an exponential function, then how you can find its derivative? So keep this in mind. The calculated value of the exponential function is e raised to power x. If you came across the function e raised to power x, then its derivative is e raised to power x as it. So this is basically the derivative of the function involving the involving the exponent. But in case you came across the function where the power of e is something else like x square or 2x or any other power, then we have to equate it differently. So just keep in your mind here that here the power is x, that's why we have e raised to power x. Otherwise, if the power is different, then its derivative will be different. That we will see in the next few lectures. So currently you have to keep this in your mind. So let's find the derivative. First we have to say that this is h of x, this is g of x, and the formula that we will apply is dy by dx is equals to h dash of x into g of x plus h of x into g dash of x. So first we have to find what is unknown in this formula. Unknown is h dash of x and g dash of x. So we have to find these two. So let's find it out. H dash of x is equals to d by dx of, what is h of x? That is e raised to power x. So its derivative will be, as I already told you, e raised to power x is e raised to power x. And then g dash of x, derivative of g dash of x is 4 minus under root x. So its derivative will be d by dx of 4 minus d by dx of under root x. So as 4 is constant, so derivative will be 0 minus the derivative of under root x will be, as x power of x is 1 by 2, so I'll move the power here as 1 by 2, and minus 1 by 2 minus 1 is minus 1 by 2. So it will be equals to minus 1 over 2 under root x. So we have to put these values in the formula. Which formula? This one. So in this formula we will have dy by dx. Now h dash of x is e raised to power x, so I'll write e raised to power x here. Then what is g of x? G of x is this, so 4 minus under root x plus, what is h of x? H of x is this, so I'll write e raised to power x, and g dash of x is what? This is g dash of x, so like minus 1 over 2 under root x. So if I further simplify it, take e raised to power x as common, but we will get 4 minus under root x minus 1 over 2 under root x. So this is the derivative of the given function involving exponential function. So this is how you can find the derivative by using the product rule, and where you came across the exponential function in the product form. Let's have one more example where we will see the exponent having the power other than x, so that you can have a clear concept how you can find the derivative in such a case. If you came across the function y is equals to 9x e raised to power x cube, so how you will find its derivative using the product rule? Let's find it out. First we will bifurcate the functions, as this is g of x, this is h of x, and the formula is dy by dx is equals to g dash of x into h of x plus g of x into h dash of x. So we have to find the unknown quantities, that is g dash of x and h dash of x, that is the derivative of g of x and derivative of h of x. So we'll find them as g dash of x is equals to d by dx of g of x. G of x is 9x. We'll write 9x here. Derivative, as 9 is constant, 9 will come out. So d by dx of x you have to find, and it will be 9, as the derivative of x is 1. Then we have h dash of x, that is d by dx of e raised to power x cube. Now how you will find the derivative of such function? One method is you can find it by using the chain rule, but currently we have not discussed the chain rule, so I will not prefer it here to use the chain rule. But shortcut method is, how you can find it is, first you have to write this function as it is. I'm talking about this derivative. Derivative will be like e raised to power x cube. Then find the derivative of its power, that is x cube. Okay, so what is we will get is e raised to power x cube dot, as x cube 3 will move here and subtract 1 from the power, it will become 3x square. So this is the derivative of e raised to power x to the power 3, or e raised to power x cube. So 3x square e raised to power x cube. Now for your convenience, if you say again, I'll repeat the derivative of this e raised to power x cube as what I have done. I have done it as we have got, well, as I already told you that the derivative of e raised to power x is e raised to power x. Why? Because when we take the derivative of its power, it will become 1. So multiplying it with 1 is the same, so that's why it is equals to e raised to power x. So but when we came across e raised to power 2x, then its derivative will be, first we'll write the function as it is, that is 2x. Then we need to take the derivative of its power, that is 2x. Then the derivative of 2x, what will be the derivative of 2x? It will be 2, because the power of, derivative of x is 1, so I'll write 2 here. The derivative will become 2 e raised to power 2x. Same is the case if you came across e raised to power x. Again, first you have to write the given function as it is, x e raised to power x cube. Then you have to take the derivative of its power, that is x cube. So what you will get? You will get e raised to power x cube as it is, and the derivative of x cube is 3x square. So this is how you can find the derivative of the exponential functions when there is an exponential function in function with the power other than x. So we move towards the question now. Put the value of g dash of x and h dash of x in this formula. We get dy by dx equals to, what is g dash of x? That is equals to 9. H of x is this e raised to power x cube plus g of x is what? G of x is 9x, and what is h dash of x? H dash of x is 3x square e raised to power x cube. So we further simplify it, we will get 9 e raised to power x cube plus 27 x cube e raised to power x cube, and if I take the common as 9 e raised to power x cube, we will get 1 plus 3x cube. So this is how you can find the derivative of the functions involving the exponential functions or in multiplication with other functions. So that's all from today's lecture. In our next lecture, we will discuss the quotient rule of derivative. Thank you. Thank you for watching. If you like this video, please don't forget to subscribe our channel math.com for more updates. Thank you.